Hello, in this lecture we will find out the area of the semicircle using 4 different methods. In the drawing we have a semicircle that is inscribed by triangle ABC. Triangle ABC is a right triangle. Side CB of triangle ABC equals to 5 units. Side AB of triangle ABC equals to 12 units, and angle ABC of triangle ABC equals to 90 degrees. And we want to find out the area of this semicircle that is inscribed by triangle ABC. So we will start with the first method. In the first method we will define the center of the semicircle as point O. And actually, line segment OB is the radius of this semicircle because of the fact that line segment OB starts from the center of this semicircle, that is to show from point O, and ends at point B, that is a point of the semicircle itself. Therefore, OB is the radius of this semicircle. We will define the radius of the semicircle as R, so OB will be equal to R. And actually AB minus OB equals to AO. Again, AO equals to AB minus OB. I will write it down. AO, line segment AO equals to AB minus OB. AB equals to 12 units. It is given as in the question. OB is the radius of the semicircle, that is to say it equals to R. So in conclusion, we found out that line segment AO equals to 12 minus R units. So we can write here that AO equals to 12 minus R units. And we will define the point of tangency of tangent AC with this semicircle as point D. This point we will define as point D. Then we will join together points O and D by a straight line. Actually, line segment OD is the radius of the semicircle because of the fact that line segment OD starts from the center of this semicircle, that is to say from point O, and ends at point D, that is a point of the semicircle itself. Therefore, OD is the radius of this semicircle, that is to say it equals to R. Okay? In the next step, we will find out the length of the hypotenuse AC of triangle ABC. And we will find it according to the Pythagoras theorem. So we will focus on the right triangle, triangle ABC. In the right triangle, triangle ABC, according to the Pythagoras theorem, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars in any right triangle, and especially in the right triangle ABC. So actually in the right triangle, triangle ABC, the square of the hypotenuse is AC squared because the hypotenuse is AC, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to CB squared plus AB squared. I'll repeat again. On the right triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC squared equals to CB squared plus AB squared. So AC squared, according to equation number 1, equals to CB squared. CB equals to 5 units, according to what is given us in the question. So CB squared will be equal to 5 squared. 5 squared is 25. Plus AB squared. AB equals to 12 units. Therefore, AB squared will be equal to 12 squared, and 12 squared is 144. So in conclusion, we found out that according to equation number 1, AC squared equals to 25 plus 144. 25 plus 144 is 169. So we found out that according to equation number 1, AC squared equals to 169. Here we will take a root out of this equation, equation number 1, and we will get that AC, the hypotenuse of triangle ABC, equals to the square root of 169, and the square root of 169 is 13. So we found out that AC, the hypotenuse of triangle ABC, equals to 13 units. Okay, so we can write here that AC equals to 13 units. In the next step, I will present to you a new rule, rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I'll repeat on rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have a circle and the center of this circle is at this point, we will define the center of the circle as point O. and we also have tangent AB. This tangent AB, is tangent to this circle at this point. We define the point of tendency as point M. So here M is the point of tendency of tangent AB with this circle. Then we will join together points O and M by a straight line. Actually, OM is the radius of this circle because of the fact that it starts from the center of the circle and ends at point M. That is the point on the circle itself. Therefore, OM is the radius of this circle. So, according to rule number 1, a tangent to a circle, that is to say AB, is perpendicular to the radius drawn to its point of tendency. So this radius, the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, according to rule number 1, the tangent AB is perpendicular to this radius. That is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. So whenever you have a radius that is drawn to the point of tendency, like in this drawing, then the tangent will be perpendicular to that radius. In this case, the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? So we actually can implement rule number 1 in our drawing. Because here the tangent CA is tangent to this semicircle at point D. Point D is the point of tangency of tangent CA with this semicircle. Therefore, and we see in the drawing that the radius OD, it is drawn to the point of tangency. That is to say, it is drawn to point D, that is the point of tangency of tangent CA with this semicircle. Therefore, according to rule number 1, whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. That is to say, CA will be perpendicular to the radius DO. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And in the next step, we will prove that the right big triangle ABC, is similar to the right small triangle ADO. Okay, it's perpendicular to the green small right triangle ADO. So we will focus on the right big triangle ABC, and the small green right triangle ADO, and we will prove that those two triangles are similar to each other. Okay? Triangle ABC and triangle ADO. So, why triangle ABC is similar to the green triangle? First of all, we know that those two angles, they are equal to each other, they are both right angles. So this angle that is angle ABA of triangle, this angle that is angle ABC of triangle ABC is equal to this angle that is actually angle ADO of the green triangle. And both angles are equal to 90 degrees. I'll repeat again. Angle ABC of triangle ABC is equal to angle ADO of the green triangle, and both angles are right angles, that is to say they are equal to 90 degrees. And we also have this angle is a common angle. It belongs both to triangle ABC and it also belongs to the green triangle. So we can write down that angle A equals to itself. Angle A equals to angle A. It's a common angle that belongs to both triangles. I'll repeat again. Angle A equals to itself. It is a common angle that belongs to both triangles. And actually, those two angles, they are also equal to each other according to third angle theorem. So this angle that is actually angle ADB of triangle ABC, it is actually angle ACB. Is equal to this angle that is actually angle AOD of the green triangle. And those angles, they are equal to each other according to third angle theorem. So what is third angle theorem? I'll repeat again, first of all. Angle ACB of triangle ABC equals to angle OAB of the green triangle according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And we can see it here. We can see the rule here. Here we have two angles of the big right triangle, triangle ABC, that congruent to two angles of the green triangle. So we have here two pairs of angles that congruent in those two triangles. Therefore, according to third angle theorem, the third pair of angles, those angles that are defined as the third pair of angles, must also congruent. Why? Because they are complementary to 180 degrees. We know that the sum of the angles in any triangle is equal to 180 degrees. So if we have two angles that congruent in two triangles, then the third angle in any triangle is complementary to 180 degrees. So they must be equal to each other because the value of the third angle is actually 180 degrees minus the sum of the two other angles that are equal to both triangles. Therefore, the third angle must also be equal in those two triangles. Okay, so we actually proved that all three angles in triangle ABC congruent to all three angles in the green triangle. Therefore, we proved the triangle ABC is similar to the green triangle according to angle similarity rule. So I will write it down. We actually proved that triangle ABC is similar, this is the sign of similar, to triangle ADO, the green triangle, according to angle similarity rule. I'll repeat again. We actually proved that triangle ABC is similar to triangle ADO, the green triangle, according to angle similarity rule. And what is angle similarity rule? Angle similarity rule is that if you prove that all angles in one triangle congruent to all angles in another triangle, then you proved that those two triangles are similar to each other according to angle similarity rule. And from the fact that triangle ABC is similar to the green triangle, we will conclude that CB over CA in triangle ABC, CB over CA in triangle ABC is equal to DO over AO in the green triangle. So I will repeat again. We can conclude from the fact that the two triangles are similar to each other, that CB over CA in the big right triangle, triangle ABC, is equal to DO over AO in the green triangle. Okay? But we know that CB equals to 5 units. It is given us in the question. We have already found out that CA, the hypotenuse of triangle ABC, equals to 13 units. DO is the radius of the semicircle, that is to say it equals to R, and we have already found out that AO equals to 12 minus R. So in conclusion, we found out that according to equation number 2, 5 over 13 equals to R over 12 minus R. Here we will cross multiply equation number 2 and we will get that 5 times 12 minus R equals to 13R. Here we will open the brackets of equation number 2 and we will get that 5 times 12 is 60. 5 times minus R is minus 5R and it equals to 13R. Here we will add 5R to this equation, equation number 2, and we will get that 13R plus 5R is 18R, and 18R equals to 60. So here we will divide equation number 2 by 18, and we will get that R, the radius of the semicircle, equals to 60 over 18. So here we will divide both the numerator and the denominator of this number by 6, and we will get that 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units, and the area of the semicircle will be equal the area of the semicircle Here the brackets are the sign for the area. This means the area of the semicircle is equal to pi r square over 2. So it is pi over 2, r equals to 10 over 3. Therefore r square equals to 10 over 3 square. So it is pi over 2, and 10 over 3 is 100 over 9. And 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, we finished with the first method. In the next step, I will present to you how to find out the area of this semicircle according to a second method. I will not repeat on the things that we did in the first method. So we actually know that this is the center of the circle. It is O. O is the radius. OA is 12 minus R. Here we have, this is point D. DO is the radius of the semicircle, that is to say it equals to R. And we also found out that this angle is equal to 90 degrees, and this angle is also equals to 90 degrees. Okay. And we have already found out that the hypotenuse AC of triangle ABC equals to 13 units. So, in the second method, I will present to you a new rule. It is rule number 2, or two tangents theorem. So, what is rule number 2 of two tangents theorem? Rule number 2, or you can call it also two tangents theorem. According to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So I will read rule number 2 of two tangents theorem again. According to rule number 2 of two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 2 or 2 tangents theorem? The meaning of rule number 2 is that if we have a circle and we also have an external point of this circle, here point P is an external point of this circle. Why point P is an external point? Because of the fact that point P is not located inside this circle nor on this circle, but it is located outside of this circle. Therefore, it is defined as an external point. So if from the external point, point P, we will draw two tangents to this circle. So the first tangent will be this tangent. And we will define the touching point between the tangent and the circle as point A. And then we will draw a second tangent to this circle from point P. And we will define the touching point between the second tangent and the circle as point B. So here, according to rule number 2, the lengths of two tangents, in this way the length of the first tangent is PA and the length of the second tangent is PB. So the lengths of two tangents from a common external point to a circle are equal. So the common external point is point P, and we draw the two tangents from the common external point to the circle. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, PA equals to PB. Okay, so whenever you have a common external point of a circle and you draw two tangents to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. Okay, so actually we can implement rule number 2 in our drawing, because in our drawing we have the common external point, point C. From point C we have the first tangent is CB. CB is tangent to the semicircle at point B. And the second tangent is CD. CD is tangent to the circle, to the semicircle at point D. And according to rule number 2, CB equals to CD. Okay, CB equals to CD according to rule number 2. But it is given in the question that CB equals to 5 units. So from this equation, we will derive that CD also equals to 5 units. And so here we can write down that CD equals to 5 units. And what is the value of AD? You can see from the drawing that AD equals to CA minus CD. Again, AD equals to CA minus CD. Okay, so AD equals to CA. We have already found out that CA, the hypotenuse of triangle ABC, equals to 13 units. Minus CD, we just right now found out that CD equals to 5 units. So in conclusions, AD equals to 13 minus 5, that is to say, AD equals to 8 units. AD equals to 8 units. Okay. So we can write here that AD equals to 8 units. So we will focus on the right triangle, triangle ADO, on the green right triangle, triangle ADO, and we will implement the Pythagoras theorem in the right green triangle, triangle ADO. Okay? So according to the Pythagoras theorem, in the right green triangle, triangle ADO, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? So the hypotenuse in the green triangle is AO because it is in front of the right angle. So the square of the hypotenuse is AO square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to DO square plus AO square. DO square plus AD square. Okay, according to the Pythagoras theorem, in the right triangle, green right triangle, triangle AOD, AO square equals to DO square plus AD square. So AO is 12 minus R. Therefore, AO square is 12 minus R square. And it equals to DO square. DO is R, DO square is R square, plus AD square. AD equals to 8 units, so AD square is 8 square. 8 square is 64. So here we will open the brackets on this side of equation number 1, and we will get that 12 minus R square equals to 12 square is 144 plus R square minus 24R, and it equals to R square plus 64. Here we have R square on both sides of equation number 1, so R square will get cancelled, and what is left from equation number 1 after we cancelled R square, what is left is actually in this side we have 144 minus 24R, and here we have 64. Here we will subtract 64 from equation number 1, and we will get that here we will subtract 64 from this equation number 1, and we will get that 144 minus 64 is 80, so we have 80 minus 24R equals to 0. Here we will add 24R to this equation number 1, and we will get that 24R equals to 80 here we will divide equation number 1 by 24, and we will get that the radius of the semicircle R equals to 80 over 24. Here we will divide both the numerator and the denominator of this number by 8, and we will get that 80 over 8 is 10, and 24 over 8 is 3. So we found out that according to equation number 1, R equals to 10 over 3 units. R, the radius of the semicircle, equals to 10 over 3 units. And the area of the semicircle will be equal to the area of the semicircle. This is the sign for the area of the semicircle. Will be equal to pi r square over 2. So it is pi over 2, and r is 10 over 3, so r square is 10 over 3 square. So it is pi over 2, and 10 over 3 square is 100 over 9. And 100 over 2 is 50, so in conclusion we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the second method. In the next step, I will present to you how to find out the area of this semicircle according to the third method. In the third method, we will draw the mirror image of this figure, and then we will join this figure with its mirror image, and in this way we will create a circle that is inscribed by an isosceles triangle. Okay? I will do the drawing, and you will see what I mean. Okay? So here. So here we have the original image, the original figure is this side of the drawing. We have triangle ABC that is right triangle with side BC that equals to 5 units, side AB equals to 12 units, and angle ABC is a right angle, and we have already found out that AC, the hypotenuse of triangle ABC, equals to 13 units. And I drew the mirror image of this figure, and I got this figure. This figure is the mirror image of the original figure, this figure. So and we will define this point as point D, and because of the fact that this figure is a mirror image of this figure, and AC equals to 13 units, therefore AD also must be equal to 13 units, because it is a mirror image. And because of the fact that BC equals to 5 units, then dB must be also equal to 5 units. This is a right angle, okay, because this is triangle, right triangle, triangle ABC is a right triangle, therefore angle ABC is a right angle. And this is also a right angle because it is the mirror image of the original figure. And DC is 5 plus 5, that is to say DC, the base of the isosceles triangle, triangle ADC equals to 10 units, and the height to the base is AB, that equals to 12 units. So here we can find out the area of this isosceles triangle, triangle ADC. The area of the isosceles triangle, triangle ADC is equal to the base of the triangle times the height to the base over 2. This is the formula for the area of any triangle. Okay? So the area of the isosceles triangle, triangle ADC is equal to the base of triangle ABC, that is actually DC. The base is DC. The height to the base is AB because the height creates 90 degrees with the base, and AB indeed creates 90 degrees with the base DC. So the height is AB over 2. So the area of the isosceles triangle, triangle ADC is equal to DC is 10 units, AB is 12 units, divided by 2. So the area of the isosceles triangle, triangle ADC is equal to 10 times 12 is 120, and 120 over 2 is 60. So we found out that the area of the isosceles triangle, triangle ADC, this triangle, is equal to 60 square units. Okay? And then we know that the radius of any circle that is inscribed by a triangle is equal to the area of the triangle that blocks the circle over the semi-perimeter of the triangle that blocks the circle. Okay? And in this case, so I write down the formula for the radius of a circle that is inscribed by a triangle. The radius of the circle that is inscribed by a triangle is equal to the area of the triangle that blocks the circle. In this case is triangle ADC. As you can see, triangle ADC blocks this circle, or this circle is inscribed by triangle ADC over the semi-perimeter of triangle ADC that blocks the circle. And what is the semi-perimeter of any triangle? The semi-perimeter of any triangle is equal to the perimeter of the triangle over 2. So we already found out that the area of the isosceles triangle, triangle ADC, equals to 60 square units, and the semi-perimeter is equal to the perimeter of triangle ADC over 2. The perimeter of triangle ADC is AD plus AC plus DC. AD plus AC plus DC. And if we divide the perimeter by 2, we will get the semi-perimeter. AD is 13, AC is 13, DC is 10, all divided by 2. 13 plus 13 is 26, and 26 plus 10 is 36, and 36 over 2 is 18. So we found out that the semi-perimeter of triangle ABC equals to 18 units. Therefore, the radius of the circle that is inscribed by a triangle is equal to, in this case, it's 60 over 18. 60 over 18, so we will divide both the numerator and the denominator of this number by 6. 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the circle equals to 10 over 3. That is actually also the radius of the semicircle, because the circle is composed of two semicircles, our two semicircles. Therefore, the radius of the circle is also the radius of the semicircle. So the radius of the semicircle is 10 over 3, and the area of the semicircle is equals to pi r squared over 2. So it is pi over 2. R is 10 over 3. And r squared is 10 over 3 squared. So it is pi over 2. 10 over 3 squared is 100 over 9. So, and 100 over 2 is 50. So in conclusion, we found out that the area of our semicircle is equal to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. We finished with the third method. In the next step, I will present to you how to find out the area of this semicircle according to the fourth method. I will not repeat on the things that we did in the previous methods. We know that this is point O, this is 2n, OB is the radius, AO equals to 12 minus R. Here we have point D. DO is the radius of the semicircle, that is to say it equals to R. And we have those two angles are right angles. They are equal to 90 degrees. Okay. And we have already found out that AC, the hypotenuse of triangle ABC, is 13 units. So we will define the angle at vertex A of the right triangle ABC as theta. This angle is defined as theta. And we focus on the right triangle ABC. So on the right triangle ABC, sinus theta on the right triangle ABC, sinus theta equals to CB over CA. CB equals to 5 units and CA equals to 13 units. So in conclusion, we found out that sinus theta, according to equation 1, is equal to 5 over 13. In the next step, we will focus on the small right triangle, triangle ADO. Or we will focus on the green right small triangle, triangle ADO. What is the value of sinus theta in the green triangle? It is also a right triangle. So sinus theta in the green triangle, triangle ADO, will be equal to DO over AO. We know that DO equals to R and AO equals to 12 minus R. So in conclusion, we found out that according to equation number 2, sinus theta equals to R over 12 minus R. Okay, according to equation number 2, sinus theta equals to R over 12 minus R. In the next step, we will create equation number 3. In equation number 3, equation number 3 states that sinus theta, according to equation number 1, that is 5 over 13, must be equal to sinus theta according to equation number 2, that is actually R over 12 minus R. I'll repeat again on equation number 2. Equation number 2 states that sinus theta according to equation number 1, that is actually 5 over 13, must be equal to sinus theta according to equation number 2, that is R over 12 minus R. Here we will cross multiply equation number 3, and we will get that five times 12 minus R equals to 13R. Here we will open the brackets on this side of equation number 3, and we will get that 5 times 12 is 60. 5 times minus R is minus 5R, and it equals to 13R. Here we will add 5R to this equation, equation number 3, and we will get that 13R plus 5R is 18R, and it equals to 60. Here we will divide the equation number 3 by 18, and we will get that R, the radius of the semicircle, equals to 60 over 18. Okay, so we will divide both the numerator and the denominator of this number by 6, and we will get that 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units. Therefore, the area of the semicircle will be equal to the area of the semicircle equals to pi r square over 2. So it is pi over 2. R is 10 over 3, and r square is 10 over 3 square. So it is pi over 2, and 10 over 3 square is 100 over 9. So here we have 100 over 2 is 50, so we found out that the area of the semicircle is equal to 50 pi over 9 square units. In terms of numbers, it equals to 17.45 square units. So we finished with the fourth method. In the next step, I will summarize the lecture. Actually, we wanted to find out the area of this semicircle. We found out the area of this semicircle in 4 different methods. In the first method, I repeat that we have here a semicircle that is inscribed by triangle ABC that is a right triangle. CB equals to 5 units, AB equals to 12 units, angle ABC equals to 90 degrees. And we want to find out the area of this semicircle. We defined the center of the semicircle as point O. OB is the radius. And AO equals to AB minus OB. Again, line segment AO equals to AB minus OB. AO equals to AB minus OB. AB equals to 12 units, OB equals to R, so line segment AO equals to 12 minus R. Line segment AO equals to 12 minus R. Then we focused on the right triangle, triangle ABC, and we found out the length of the hypotenuse AC according to the Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, so the square of the hypotenuse is AC squared, and it equals to CB squared plus AB squared. CB equals to 5 units, so CB squared is 5 squared, 5 squared is 25. AB equals to 12 units, so AB squared is 12 squared, 12 squared is 144, so according to equation number 1, AC squared equals to 25 plus 144. 25 plus 144 equals to 169, so we found out that according to equation number 1, AC squared equals to 169. We took out of this equation number 1, and we found out that AC equals to the square root of 169, and the square root of 169 is 13, so we found out that the hypotenuse AC of triangle ABC equals to, of the right triangle ABC equals to 13 units. Then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have a circle and AB is tangent to this circle at point M, M is the point of tendency of tangent AB with this circle, and we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. In this case, according to rule number 1, the tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So we can implement rule number 1 in our drawing, because in our drawing we have tangent CA is tangent to the semicircle at point D. Point D is the point of tendency of tangent CA with this semicircle. And we have the radius OD that is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of tangent AC with this semicircle. Therefore, according to rule number 1, the tangent CA will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. And because of the fact that this angle is a right angle, then the green triangle, triangle ADO, is a right triangle. Then we proved that triangle ABC is similar to the green triangle, triangle ADO. Why they are similar to each other? Because first of all, we have those two angles, they are both equal to each other, they are both equal to 90 degrees. So angle ABC equals to angle AOD equals to 90 degrees. Angle A equals to itself, it is a common angle that belongs to both triangles. And we have those two angles, they are also equal to each other according to third angle theorem. Angle ACB equals to angle AOB according to the third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And we have here those two angles in triangle ABC congruent to those two angles in the green triangle. So we have two pairs of angles that congruent to each other in those two triangles. Therefore, the third pair of angles, those are defined as the third pair of angles, must also congruent. Why they congruent? Because they are actually complementary to 180 degrees. We have two angles that congruent to each other in those two triangles, and the third angle must complete the sum of the angles in any triangle to 180 degrees. Because the sum of the angles in any triangle is equal to 180 degrees. So the value of the third angle is 180 degrees minus the sum of the two other angles. And the two other angles are both equal in those two triangles. Therefore, 180 degrees minus the two other angles that equal must be equal the same in both triangles. So they have actually the same angles. The side of the third angle must be equal in both triangles. So we actually proved that all three angles in triangle ABC congruent to all three angles of the green triangle. Therefore, we proved that triangle ABC is similar to triangle AOD, the green triangle, according to angle similarity rule. And from the fact that triangle ABC is similar to triangle AOD, we will conclude that CB over CA in triangle ABC equals to DO over AO in the green triangle. Okay, CB over CA in triangle ABC equals to DO over AO in the green triangle. But CB equals to 5 units, CA equals to 13 units, DO equals to R, and AO equals to 12 minus R. So we found out that according to equation number 2, 5 over 13 equals to R over 12 minus R. We cross multiplied the equation number 2 and we got that 5 times 12 minus R equals to 13R. We open the brackets on this side of equation number 2 and we got that 5 times 12 equals to 60. 5 times minus R equals to minus 5R. We added 5R to this equation, equation number 2. So 13R plus 5R is 18R. So we got that 18R equals to 60 according to equation number 2. We divided equation number 2 by 18 and we got that R, the radius of the semicircle, equals to 60 over 18. We divided both the numerator and the denominator of this number by 6 and we got that 60 over 6 is 10 and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3. Therefore, the area of the semicircle, the area of the semicircle equals to pi r squared over 2. So it is pi over 2 and r is 10 over 3. R squared is 10 over 3 squared. So it is actually pi over 2 and 10 over 3 squared is 100 over 9. So and 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the first method. Then I presented to you how to find out the area of the semicircle according to a second method. in the second method, I presented to you a new rule. According to the new rule, that is actually rule number 2 or two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of two tangents theorem? The meaning of two tangents theorem is that if we have a circle and we have point P that is a common external point, and from point P we will draw two tangents to this circle, then the lengths of those two tangents will be equal to each other. That is to say, PA will be equal to PB. The lengths of two tangents, that is to say PA and PB, from a common external point, that is to say from point P to a circle, to points A and B, are equal. That is to say PA equals to PB. So whenever you draw two tangents to a circle from a common external point of that circle, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. And we can implement rule number 2 in our drawing, because in our drawing we have the common external point, point C. From point C we have tangent CB and tangent CD. According to two tangents theorem, they are equal to each other. That is to say CB equals to CD according to rule number 2. But we know that CB equals to 5 units. It is given us the equation. So from this equation we will derive that CD also equals to 5 units. Here CD also equals to 5 units. But we know that CA equals to 13. CD equals to 5. And what is the value of DA? DA equals to CA minus CD. DA or AD equals to CA minus CD. CA is 13, CD is 5. So DA or AD equals to 13 minus 5. That is to say AD equals to 8 units. OD equals to R, and AO equals to 12 minus R. So we focused on the right green triangle, triangle ADO, and we implemented the Pythagoras theorem and the right green triangle, triangle ADO. According to the Pythagoras theorem, in the right green triangle, triangle ADO, AO square plus DO square equals to AD square. AO square equals to ADO square plus AD square. AO equals to 12 minus R. So AO square equals to 12 minus R square. DO square equals to R. So DO equals to R. So DO square equals to R square. AD equals to 8, so AD square equals to 8 square, 8 square is 64. So in conclusion, according to equation number 1, 12 minus R square equals to R square plus 64. We open the brackets on this side of equation number 1, and we found out that 12 minus R is 12 square is 144 plus R square minus 24R. It equals to R square plus 64. We have R square on both sides of equation number 1, so R square will get cancelled. And we left only with 144 minus 24R equals to 64. Here we subtracted 64 from this equation, equation number 1. And we got that 144 minus 64 is 80. So we got that 80 minus 24R equals to 0. We added 24R to this equation, equation number 1, and we got that 24R equals to 80. We divided this equation, equation number 1 by 24, and we got that R equals to 80 over 24. We divided both the numerator and the denominator of this number by 8, and we got that 80 over 8 is 10, and 24 over 8 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3, and therefore the area of the semicircle equals to pi r square over 2, or it is pi over 2 and r is 10 over 3, r square is 10 over 3 square. It is pi over 2 and r square is 10 over 3 square. 10 over 3 square is 100 over 9, and 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers it equals to 17.45 square units. So we finished with the second method. Then I presented to you how to find out the area of the semicircle according to a third method. In the third method, we drew the mirror image of this figure and we joined this figure with its mirror image, and in this way we created a circle that is inscribed by an isosceles triangle. Okay, this is the picture that created by combining the original image with its mirror image. We got an isosceles triangle that blocks a circle. The original image is ADB. We know that the original image is ABC. This is the original image. We know that AB equals to 12 units. We found out that AC equals to 13 units, BC equals to 5 units. It is given us the question. We know that this angle ABC is 90 degrees, and this is the mirror image. So this angle also will be equal to 90 degrees, and AC must be equal to AD, so AC is 13, so AD will be also equal to 13. BC is 5, so DB will be also equal to 5. Therefore, the base of the isosceles triangle ADC equals to 5 plus 5, that is to say, it equals to 10 units. And the height AB equals to 12 units, it is given us in the question. So we calculated the area of this isosceles triangle ADC. The area of any triangle equals to the base of the triangle times the height over 2. The base is DC, the height is AB, when we have to divide it by 2. DC is 10 units. AB is 12 units, so in conclusion we found out that the area of triangle ADC equals to 10 times 12 over 2. 10 times 12 is 120, and 120 over 2 is 60. So we found out that the area of triangle ADC equals to 60 square units. Okay, then we know that the radius of any circle that is inscribed by a triangle, like in this drawing, we can see that this circle is inscribed by triangle ADC, the isosceles triangle ADC, and the area of any triangle, and especially the radius of any triangle, and especially the radius of this triangle, will be equal to the area of the triangle that blocks the circle, that is to say the area of triangle ADC, over the semi-perimeter of triangle ADC. And we have already found out that the area of triangle ADC equals to 60 square units, and the semi-perimeter of any triangle equals to the perimeter over 2. And the perimeter of triangle ADC is AD plus AC plus DC. And if we divide the perimeter by 2, we will get the semi-perimeter. AD is 13, AC is 13, and DC is 10. 13 plus 13 is 26, 26 plus 10 is 36, and if we divide 36 by 2, we will get the semi-perimeter, that is 18. So we found out that the semi-perimeter of triangle ADC equals to 18 units, and the area of triangle ADC, the isosceles triangle ADC, is equal to 60 square units. Therefore, the radius of the circle that is inscribed in triangle ADC is equal to 60 over 18. We divided both the numerator and the denominator of this number by 6. 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the circle that is inscribed by triangle ADC equals to 10 over 3, and the radius, the circle itself is composed of the two semicircles that we are looking for. Therefore, the radius of the circle is also the radius of the semicircle. So, actually, the radius of the semicircle is equals also to 10 over 3, and the area of the semicircle is equal to pi r squared over 2. and r equals to 10 over 3. So it is pi over 2 and r is 10 over 3. And r square is 10 over 3 square. So it is pi over 2. And 10 over 3 square is 100 over 2. 100 over 9. Okay? And 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the third method. Then I presented to you how to find out the radius of the, how to find out the area of the semicircle according to the fourth method. In the fourth method, we defined the angle that is here, the angle here is angle theta. The angle at point A, we defined it as angle theta. And we focused on the right triangle ABC. In the right triangle ABC, sinus theta equals to CB over CA. You can see here, in the right triangle ABC, sinus theta equals to CB over CA. Sinus theta equals to CB over CA. CB is 5, CA is 13. So in conclusion, we found out that sinus theta equals to 5 over 13 according to equation number 1. Then we focused on the green right triangle. Here, sinus theta equals to DO over AO. In the green triangle, sinus theta equals to DO over AO. DO is R. AO is 12 minus R. So in conclusion, we found out that sinus theta equals to R over 12 minus R according to equation number 2. And according to equation number 1, sinus theta equals to 5 over 13. Then we created the equation number 3 that states that sinus theta according to equation number 1, that is 5 over 13, must be equal to sinus theta according to equation number 2, that is R over 12 minus R. Okay, then we could multiply this equation number 3, and we got that 5 times 12 minus R equals to 13R. We open the brackets of this side of equation number 3, and we got that 5 times 12 is 60, and 5 times minus R is minus 5R. We added 5R to this equation number 3, and we got that 13R plus 5R is 18R. So 18R equals to 60 according to equation number 3. Here we divided the equation number 3 by 18, and we got that R equals to 60 over 18. Here we divided both the numerator and the denominator of this number by 6. 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units, and therefore the area of the semicircle is equal to pi r square over 2. So it is pi over 2, and r is 10 over 3. R square is 10 over 3 square. 10 over 3 square is 100 over 9, so it is actually pi over 2 times 100 over 9. 100 over 2 is 50, so in conclusion we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, thank you very much.